Tonight we tackle a question you've probably whispered to yourself in the quiet of the night. Why is cancer so damn hard to beat? It's a puzzle that haunts millions, and you're about to slip into the shadowy world of your body, where a silent battle rages under the glow of your immune system's defenses. Picture it. Trillions of cells humming along, each a tiny worker in the vast factory of you, while your immune system patrols like a night watchman, scanning for trouble. But somewhere in a quiet corner, one cell goes rogue, whispering rebellion. You probably won't even notice this happening inside you. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop a comment with your city and local time. I'm curious where you're drifting off tonight. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're floating through your body's bustling metropolis, where cells divide and die in perfect rhythm, but that question lingers. Why can't your body just squash cancer before it starts? It all begins with one cell, a single traitor in the ranks. That's where cancer kicks off, and it's maddeningly sneaky. Your immune system, your body's tireless guardian, relies on a crack team of white blood cells to keep things in check. Here's the mainstream fact. Macrophages and T cells form the backbone of your innate immune system, with macrophages gobbling up damaged cells like overzealous janitors, and T cells tagging invaders for destruction like sharpshooters with a hit list. But cancer is not waving a red flag. That rogue cell is still you, just with a twisted DNA script. Maybe it's hiding in your lung, your liver, or your blood. Doesn't matter. It divides too fast, ignores the stop signals, and slips past those macrophages like a shadow in a storm. Here's the quirky tidbit. Your immune system has natural killer cells, these rogue vigilantes that don't need a formal invite to attack. They sense weird and dive in. But even they can miss cancer's quiet rebellion because it looks too much like home, like a cousin who's secretly swiping your snacks. Scientists still debate whether cancer's early stealth comes from weak immune signals or the cell's knack for posing as normal. It's like the cell's got a VIP pass to your body's club, strolling past the bouncers. You imagine your macrophages sniffing around, puzzled, because this cell isn't screaming virus or bacteria. It's just off. One cell becomes 2, then 4, then a tiny cluster, all while your immune system's distracted by louder threats. Here's a light jab. If your immune system was a security guard, it'd be the one napping during the heist. You're drifting deeper now, feeling the pulse of your body's machinery. That rogue cell's descendants are forming a tiny outpost, a tumour in the making. It's small, barely a blip, but it's there, plotting. Your immune system's still on patrol, but it's like a cop chasing a ghost in a fog. Good luck spotting it. That cancer cell's mutations, maybe a glitch in a gene like TP53, which normally slams the brakes on cell division, let it multiply unchecked. It's not loud about it either. No alarms, no sirens. Your T cells, trained to spot foreign invaders, miss it because it's flying your body's flag, like a spy with a flawless fake ID. And here's another cheeky nudge. If your body was a city, cancer's that shady new neighbour who seems normal but throws wild parties when you're not looking. The cell's quiet rebellion is just the start, and it's already outsmarting your best defences. You're sinking into this story, wondering how this tiny traitor keeps dodging the spotlight. It's not just about one bad cell. It's about how it plays the game, setting the stage for a fight your immune system's struggling to win. That question you asked? We're just starting to unravel it. You're still drifting through the humming city of your body, where that rogue cell from our last stop is starting to make waves, but let's zoom in on the guards who should have caught it. Your immune system's first line of defense is like a squad of overworked bouncers, and cancer's slipping past them with a sly grin. Picture your innate immune system as the body's rapid response team, always on call, ready to tackle invaders like bacteria or viruses before they crash the party. This is the mainstream fact. Your innate immune system, with its macrophages and dendritic cells, acts like a SWAT team, spotting and neutralizing threats using pattern recognition receptors to detect not you signals. But cancer? It's like a guest who knows the secret handshake. That rogue cell, now dividing into a small gang, doesn't trigger the usual alarms. It's not coated in the telltale markers of a virus or bacteria, so your macrophages, those big eaters we met earlier, just shrug and move on. Here's the quirky tidbit. Your innate system has these cool sensors called toll-like receptors, which are like tiny noses sniffing for trouble, but they're tuned to spot foreign patterns, not your own cells gone rogue. Cancer's too clever, dressing up in your body's own molecular clothes, making it nearly invisible. Scientists still debate whether the innate immune system's blind spot is due to cancer's mimicry or a lack of strong danger signals in those early moments. It's like cancer's whispering, "Nothing to see here," while it multiplies in the shadows. You imagine your dendritic cells, the ones that usually sound the alarm to rally T cells, standing there, confused, because this tumour's not waving a red flag. It's just a tiny cluster of cells, maybe in your pancreas or skin, quietly growing while your immune system's busy elsewhere. Feel the soft pulse of your body as you float closer to this drama. Those cancer cells are starting to form a little neighbourhood, and your innate defences are none the wiser. Macrophages patrol nearby, gobbling up dead cells or bacteria, but they miss the tumour's subtle growth. It's like watching a thief blend into a crowd, and here's a light jab. If your immune system was a detective, it'd be the one staking out the wrong coffee shop. The cancer cells keep dividing, ignoring the body's usual slow-down signals, like a group of teens sneaking into a club with fake IDs. Now picture your innate immune system trying to keep up. It's got neutrophils, those kamikaze cells that explode to take out invaders, and natural killer cells, our vigilantes from last time, who should be sniffing out anything odd. But cancer's early moves are too subtle, too you. It's not screaming, "I'm a threat," so your defences don't escalate. You can almost hear the cancer cells chuckling, knowing they've dodged the first checkpoint. And here's another nudge. Your immune system's like a parent who didn't notice their kid's new piercing, too busy with the big stuff to catch the small rebellion. As you sink deeper into this quiet battle, you sense the stakes rising. That tiny tumour's getting bolder, and your innate immune system's still playing catch-up. It's not that your defences are lazy, they're just not built for an enemy this sneaky. The cancer cells are exploiting a loophole, blending in while they grow, setting the stage for a tougher fight. You're starting to see why that question from last time, why cancer's so hard to beat, has no easy answer. It's a master of disguise, and your body's first responders are struggling to keep up. You're still gliding through the bustling cityscape of your body, where that sneaky cluster of cancer cells, the ones we saw slipping past your immune system's first responders, is getting craftier. Now, imagine those rogue cells pulling a disguise so convincing they could fool even your sharpest immune guards. This tumour's not just hiding, it's dressing up as one of the good guys. The mainstream fact here is that your adaptive immune system, led by T cells and B cells, relies on recognizing specific markers, called antigens, to spot enemies. These cells are like detectives with a photo of the suspect, trained to hunt down anything that doesn't belong. But cancer, it's a master of costume changes. Those rogue cells we met earlier are now tweaking their surface proteins to look like normal, healthy cells. They're flashing your body's own ID badge, the major histocompatibility complex MHC molecules which scream, "I'm one of you." This tricks your T cells into ignoring them. Here's the quirky tidbit. Some cancer cells even crank up a protein called PDL1, which is like a "do not disturb" sign that tells immune cells to back off. It's as if the tumour's hung a velvet rope around itself, and your T cells, bless their hearts, respect the boundary. Scientists still debate whether cancer's disguise is mostly about mimicking healthy cells, or actively jamming immune signals with proteins like PDL1. Picture your immune system as a nightclub bouncer, squinting at a fake ID that looks just legit enough to let the tumour slide by. You're floating closer now, feeling the hum of your body's defences, watching those cancer cells multiply in their cosy little hideout. They're not loud or obvious, just quietly blending in, like wallflowers at a party who are secretly spiking the punch. Here's a light jab. If your T cells were on a reality show, they'd be voted off for missing the villain hiding in plain sight. The tumour's growing, maybe in your colon or breast, and it's using its disguise to avoid the immune system's spotlight. Your B cells, which usually churn out antibodies to tag invaders, are clueless because the cancer's not waving any obvious red flags. It's like the tumour's learned your body's secret handshake and is waltzing right through the checkpoints. Now imagine your immune system trying to regroup. Those natural killer cells from earlier, the ones that don't need a formal invite to attack, are still sniffing around, but even they're thrown off by the tumour's clever costume. The cancer cells are draped in your body's own molecular markers, making them look like innocent bystanders. And here's another cheeky nudge. Your immune system's like a teacher who can't spot the kid cheating because they're using the same font as the textbook. The tumor's not just hiding, it's actively fooling your defenses into thinking it's part of the team. As you drift deeper into this silent drama, you can almost feel the frustration of your immune cells, patrolling tirelessly, but missing the enemy in their midst. The tumor's disguise isn't perfect, but it's good enough to buy time, letting that cluster grow a little bigger, a little bolder. You're starting to see how cancer plays this game, using your body's own rules against it. That tiny outpost from before is turning into a fortress, and your immune system's still struggling to catch on. The question of why cancer's so hard to beat is starting to feel like a riddle wrapped in a disguise. You're still floating through the humming streets of your body's city, where that sneaky tumor, now cloaked in its clever disguise, is getting cozy. Remember that little outpost of cancer cells we've been tracking? It's not just sitting there, it's remodeling the neighborhood to suit its needs. You're watching cancer turn its surroundings into a safe haven, like a squatter turning an abandoned lot into a fortified hideout. The mainstream fact is that your immune system relies on a healthy tissue environment to function, with cells like fibroblasts and blood vessels supporting immune patrols. But cancer, it's flipping the script, reshaping this microenvironment to protect itself. Picture the tumor as a shady developer, bribing the locals to look the other way. It secretes chemicals like growth factors that trick nearby cells into helping it grow. Fibroblasts, normally the tissue's handymen, start laying down extra scaffolding, creating a dense protective barrier around the tumor. Here's the quirky tidbit. Some tumors even recruit immune cells, like macrophages, to their side. These tumor-associated macrophages act like traitorous cops, helping the tumor instead of busting it. It's as if your immune system's own soldiers are moonlighting for the enemy. Scientists still debate whether the tumor's microenvironment takeover is driven more by its chemical signals or the body's failure to push back. You're gliding closer, feeling the pulse of this altered landscape. The tumor's not just hiding anymore, it's building a fortress. Blood vessels, which should be supplying oxygen to healthy tissue, are being rerouted to feed the tumor's greedy cells. It's like the cancer's tapped into your body's plumbing, diverting resources for its own private penthouse. Here's a light jab. If your body's a city, this tumor's like a shady contractor who somehow convinced the zoning board to approve its sketchy high-rise. You can almost see those cancer cells smirking as they reshape their surroundings, making it harder for your immune system to navigate. The tissue around the tumor is getting stiff and chaotic, like a neighborhood gone to seed, and your T cells, those sharpshooters from earlier, are struggling to squeeze through the mess. They're like cops stuck in traffic while the bad guys party. Now, imagine the tumor's new digs. It's got this dense, fibrous shield thanks to those misguided fibroblasts, and a steady supply of nutrients from hijacked blood vessels. Your immune system's still patrolling, but it's like trying to raid a bunker with a flashlight. Those natural killer cells we met before, they're circling, sensing something's off, but the tumor's new setup makes it tough to get close. And here's another cheeky nudge. Your immune system's like a delivery guy who can't find the address because the tumor's changed all the street signs. As you drift through this warped landscape, you feel the tumor's confidence growing. It's not just evading your immune system, it's creating a whole ecosystem that works in its favor. The microenvironment's now a tumor-friendly zone, with normal cells unknowingly aiding the enemy. You're starting to sense why cancer's so tough to beat. It's not just a rogue cell anymore, it's a master manipulator, turning your body's own resources against you. That little cluster from before is looking more like a stronghold, and your immune system's got a harder fight ahead. You're still drifting through the twisted streets of your body's city, where that tumor's cozy fortress, the one we saw reshaping its neighborhood, is now playing a nastier game. Picture those cancer cells smug in their hideout, not just hiding, but actively wearing down your immune system's resolve. It's like they've turned the fight into a marathon, exhausting your defenders until they're too tired to care. The mainstream fact is that your immune system's T cells and macrophages rely on sustained energy to hunt and destroy threats, using cytokines, chemical messengers, to coordinate their attacks. But cancer's got a cruel trick up its sleeve. It's flooding the scene with signals that sap your immune cell's stamina. Those T cells, the sharpshooters we've been cheering for, start to look like overworked baristas on a double shift, sluggish, unfocused, and ready to clock out. Here's the quirky tidbit. Some tumors crank up a molecule called IDO, which starves T cells of tryptophan, an amino acid they need to stay sharp. It's like the tumours spiked their coffee with decaf, leaving them dazed while it keeps growing. Scientists still debate whether this immune exhaustion is mostly due to the tumour's chemical sabotage, or your body's own overzealous response burning out its defences. You're floating closer now, feeling the heavy air around the tumour's stronghold. Those cancer cells are pumping out signals like IL-10 and TGF-beta, which act like a lullaby, telling your T-cells to chill out. Your macrophages, those hungry janitors from earlier, are getting roped in too, turning into those traitorous tumour-associated macrophages we met last time. It's like the tumour's throwing a party, and your immune system's too tired to crash it. Here's a light jab. If your T-cells were athletes, they'd be benched for falling asleep during the game. You can almost see them stumbling, their receptors dulled by the tumour's tricks. The cancer's not just hiding in its fortified neighbourhood, it's wearing down anyone who gets close. Your natural killer cells, those rogue vigilantes, are still circling, but even they're starting to flag, confused by the tumour's calming signals. It's like trying to stay awake during a boring lecture, and the tumour's the professor droning on. Now picture your immune system struggling to rally. Those cytokines meant to rev up the troops are being hijacked or drowned out by the tumour's chemical fog. Your T-cells are expressing checkpoint proteins, like PD-1, which make them hit the brakes instead of charging in. And here's another cheeky nudge. Your immune system's like a phone with a dying battery, and the tumour's got the only charger, holding it just out of reach. The tumour's growing bolder, its cluster expanding while your defenders are stuck in a haze of exhaustion. As you glide through this quiet battlefield, you feel the weight of the fight. The tumour's not just outsmarting your immune system, it's draining its will to keep going. That fortress from before is looking more secure, with your immune cells too worn out to mount a proper siege. You're starting to see why cancer's such a tough opponent. It's not just sneaky, it's relentless, turning your body's own defenders into tired bystanders. The question of why it's so hard to beat feels heavier now as the tumour tightens its grip. You're still gliding through the foggy streets of your body's city, where that tumour's fortress, now a smug little stronghold, is playing dirty to keep your immune system at bay. Those exhausted T-cells we saw last time, stumbling like overworked night shift workers, are up against a new trick. Cancer's rewriting its own rulebook. It's not just hiding or tiring out your defences, it's changing its DNA faster than you can blink. The mainstream fact is that your immune system's killer T-cells are designed to lock onto specific antigens, like a missile zeroing in on a target, to eliminate cells that don't belong. But cancer is like a shapeshifter in a bad sci-fi flick, mutating its genes to throw off your T-cell's aim. Every time your immune system thinks it's got the tumour's number, the cancer cells tweak their DNA, creating new variants that dodge recognition. Here's the quirky tidbit. Some tumours rack up mutations so fast they're like a genetic slot machine, spitting out new cell types that keep your immune system guessing. It's as if the tumour's playing a game of whack-a-mole, and your T-cells are swinging blindfolded. Scientists still debate whether cancer's mutation frenzy is driven by random errors during cell division or a deliberate survival strategy. You're floating closer, feeling the chaotic buzz around the tumour's hideout. Those cancer cells, descendants of that rogue we met way back, are churning out new versions of themselves, each with slightly different surface markers. Your T-cells, trying to keep up, are like detectives chasing a suspect who keeps changing disguises. Blonde wig one day, fake moustache the next. Here's a light jab. If your immune system was a cop, it'd be filling out paperwork while the tumour's halfway to a new identity. The tumour's not just growing, it's diversifying, creating a patchwork of cells that makes it harder for your immune system to pin down. Those macrophages from earlier, the ones that should be gobbling up threats, are stuck in the tumour's manipulated neighbourhood, confused by the ever-changing faces of their target. It's like trying to catch a chameleon in a kaleidoscope. Now, picture the tumour's genetic chaos in action. A mutation in a gene like KRAS or EGFR lets some cancer cells grow even faster, while others might flip on a new protein to dodge your natural killer cells. Those vigilantes we keep rooting for? They're still prowling, but the tumour's mutations make it like chasing a ghost that keeps switching costumes. And here's another cheeky nudge. Your immune system's like a librarian trying to catalogue a book that rewrites itself every night. The tumour's not just a single enemy anymore, it's a whole gang with new tricks up their sleeves. As you drift through this swirling mess, you feel the tumour's confidence surging. Its fortress is thriving thanks to that manipulated microenvironment, and now its genetic mutations are adding layers of complexity. Your immune system's still fighting, but it's like battling a hydra. Cut off one head, and two more grow back with different faces. You're starting to see why cancer's such a slippery foe. It's not just outsmarting your defenses, it's rewriting the rules of the game. That question about why it's so hard to beat? It's feeling more like a chase through a genetic maze. You're still gliding through the chaotic streets of your body's city, where that tumor's fortress, now a buzzing hive of mutant cells, is pulling another sly move. Those cancer cells, fresh off their genetic makeover spree, aren't just dodging your immune system. They're hijacking your body's supply lines to fuel their takeover. Picture the tumor as a greedy warlord, tapping into your blood vessels to keep its rebellion alive. The mainstream fact is that your immune system needs a steady flow of nutrients and oxygen, delivered by blood vessels to power its patrols and attacks against threats like infections or rogue cells. But cancer's got a knack for angiogenesis, the process of sprouting new blood vessels, and it's using it like a master thief hotwiring a car. The tumor secretes chemicals like VEGF that trick your body into building a private pipeline straight to its doorstep, ensuring it gets all the fuel it needs to grow. Here's the quirky tidbit. Some tumors are so good at this they create leaky vessels, sloppy and chaotic, which makes it harder for your immune cells to navigate the area. It's like the tumor's built a private highway with potholes that only slow down your T cells. Scientists still debate whether tumors induce angiogenesis purely for their own benefit, or if your body's natural repair instincts get hijacked in the process. You're floating closer now, feeling the pulse of these new, twisted blood vessels snaking toward the tumor's stronghold. Those cancer cells, the ones we've been tracking since that first rogue, are thriving. Their fortress expanding as fresh blood brings oxygen and nutrients. Your immune system's still trying to fight, but it's like sending troops through a swamp while the enemy's got an express lane. Here's a light jab. If your blood vessels were a delivery service, the tumor's basically bribed the driver to skip everyone else's packages. You can almost see those cancer cells gorging on nutrients, growing bigger and bolder, while your T cells and macrophages struggle to keep up. Those natural killer cells from earlier, they're still prowling, but the tumor's new vascular network is like a maze, making it tough for them to reach the action. It's as if the cancer's built a moat around its fortress, and your immune system's stuck on the wrong side. Now picture the tumor's setup. A sprawling network of leaky, chaotic blood vessels feeding its every whim. Your immune cells, like those exhausted T cells we saw before, are trying to push through, but the environment's a mess. Swollen, congested, and hard to navigate. And here's another cheeky nudge. Your body's like a city planner who accidentally greenlit a mall for the bad guys. The tumor's not just surviving, it's thriving, using your own blood supply to power its growth, while your immune system's left scrambling in the chaos. As you drift through this tangled web, you feel the tumor's grip tightening. Its fortress, already shielded by that manipulated microenvironment, is now a well-fed machine. Thanks to its stolen supply lines, your immune system's still in the fight, but it's like battling an enemy with an endless buffet while your troops are rationing crumbs. That question about why cancer's so hard to beat is starting to feel like a tug-of-war where the tumor's got all the leverage and your body's struggling to hold the line. You're still floating through the warped cityscape of your body, where that tumor's fortress, now plump with stolen blood vessels, is pulling off its boldest move yet. Those cancer cells, fattened up and smug in their stronghold, aren't content to just sit tight. They're packing their bags and sneaking out to new territories. This is metastasis, the tumor's sneak attack, spreading like a rumour through your body's highways. The mainstream fact is that your immune system has checkpoints, like lymph nodes, where immune cells screen travellers to catch rogue cells before they settle elsewhere. But cancer's got a knack for slipping through these checkpoints like a seasoned smuggler. Those mutant cells we've been watching, the ones with their ever-changing DNA, break off from the main tumour and drift through your blood or lymph, looking for new places to set up shop. Here's the quirky tidbit. Some cancer cells use a trick called a Neukis resistance, dodging a built-in self-destruct mechanism that should kill cells floating free without a home. It's like they've hacked their own programming to survive the journey, thumbing their nose at your body's rules. Scientists still debate whether metastasis is driven more by the tumor's aggressive mutations or weaknesses in your immune system's surveillance. You're gliding closer now, feeling the quiet tension as a few cancer cells slip into your bloodstream like stowaways on a ship. Your lymph nodes, those immune checkpoints, are supposed to act like border patrols, with T cells and dendritic cells sniffing out trouble. But these cancer cells, cloaked in their disguise from a few stops back, often slide through undetected, ready to colonize your liver, lungs, or bones. Here's a light jab. If your immune system was airport security, these cancer cells would be the ones waltzing through with a fake passport and a charming smile. You can almost see them drifting, tiny and defiant, past the macrophages we met earlier, who are too busy patrolling the tumor's main fortress to notice the escapees. Those natural killer cells, our favourite vigilantes, might catch a whiff of something off, but the metastatic cells are too quick, too slippery, blending into the flow of your body's traffic. Now, picture the tumor's breakout in action. A few cells detach, tumbling through your blood like seeds on the wind, landing in a distant organ. They start small, just a tiny outpost, but they're already plotting to build another fortress. Your immune system's still trying to keep up, but it's like chasing a swarm of fireflies in the dark. Too many directions, too little time. And here's another cheeky nudge. Your immune system's like a mall cop on a Segway, trying to catch a gang that's already hopped the fence. As you drift through this silent invasion, you feel the stakes rising. The tumor's not just a local problem anymore, it's sending scouts to new frontiers, each one ready to spark a new fight. Your immune system's checkpoints are working overtime, but the cancer cells' stealth and speed make them hard to catch. You're starting to see why cancer's such a relentless foe. It's not just fortifying its base, it's spreading, turning a single battle into a war on multiple fronts. That question about why it's so hard to beat feels like it's echoing across your body's vast landscape now. You're still drifting through the sprawling shadowed city of your body, where those metastatic cancer cells, sneaking away from their fortress, are now dodging another layer of your immune system's defenses. Remember those T cells, the sharpshooters struggling to keep up? They're part of your adaptive immune system, which is supposed to have a long memory, like a detective who never forgets a face. The mainstream fact is that your adaptive immune system builds a memory bank of past invaders, using memory T cells to recognize and quickly attack threats it's seen before, like a seasoned bouncer who knows every troublemaker by name. But cancer's playing a cruel trick here. Those slippery cells, with their ever-changing disguises, are somehow slipping out of your immune system's memory book. It's like the tumor's face keeps getting blurred in the lineup, leaving your memory T cells clueless. Here's the quirky tidbit. Some cancer cells shed their recognizable markers, like MHC molecules, making them invisible to memory T cells, almost as if they've burned their fingerprints off. It's a sneaky move, letting them start new outposts in places like your lungs or brain without triggering a rapid response. Scientists still debate whether this memory failure is due to cancer's ability to hide its markers, or your immune system's struggle to catalogue such a shape-shifting enemy. You're floating closer now, feeling the quiet frustration of your immune system as it tries to recall the tumor's profile. Those memory T cells trained to spot old foes are scanning the scene, but the cancer cells have changed just enough to slip through. It's like trying to recognize someone who's had a complete makeover since you last met. Here's a light jab. If your immune system was a librarian, it'd be flipping through an outdated Rolodex while the tumor's already changed its number. You can almost see those metastatic cells, the ones we watched sneak away last time, settling into new corners of your body unnoticed. Your lymph nodes, those checkpoints we visited, are still screening for trouble, but the cancer's new outposts are too subtle, too well disguised to raise alarms. Those natural killer cells, always on the prowl, might sense something's off, but they're not getting the full picture either. Now picture your immune system's memory bank in action, or rather, failing to act. Normally, memory T cells would rally the troops, calling in reinforcements to squash a familiar threat. But with cancer, it's like the files are corrupted. The tumor's mutations, those genetic tweaks we saw earlier, keep it one step ahead, making it hard for your immune system to say, "Hey, I've seen you before." And here's another cheeky nudge. Your immune system's like a forgetful grandparent who can't quite place the new neighbour, even though they're up to no good. As you glide through this quiet betrayal, you feel the tumor's advantage growing. It's not just spreading to new spots, it's erasing itself from your immune system's hit list, making each new outpost harder to find. Your T cells and macrophages, still worn out from the tumor's earlier tricks, are struggling to keep up with an enemy that won't stay still or familiar. You're starting to see why cancer's such a maddening foe. It's not just outrunning your defenses, It's making sure they don't even remember what to chase. That question about why it's so hard to beat is starting to feel like a memory you can't quite grasp. You're still gliding through the shadowy expanse of your body's city, where those metastatic cancer cells, now ghosting your immune system's memory, are upping their game with a new kind of sabotage. Picture that tumour, with its far-flung outposts, not just dodging your defences but launching a chemical assault to keep them at bay. It's like the cancers tossing smoke bombs to confuse your immune troops. The mainstream fact is that your immune system relies on cytokines, those chemical messengers we met earlier, to rally T cells and macrophages for a coordinated attack on threats. But cancer's turning the tables, pumping out its own chemical cocktails to paralyze your defenders. These tumor-secreted molecules like IL-10 or TGF-beta act like a fog machine, dulling your immune cells' senses and slowing their response. Here's the quirky tidbit. Some tumors even release adenosine, a molecule that's like a sedative for your T cells, making them act like they've just binged a Netflix marathon, too groggy to fight. It's as if the tumors slipped a sleeping pill into your immune system's coffee. Scientists still debate whether this chemical warfare is the tumor's primary weapon, or if your immune system's own signals get scrambled in the chaos. You're floating closer now, feeling the heavy, almost syrupy air around the tumor's strongholds. Those cancer cells, whether in the original fortress or the new outpost we tracked last time, are flooding the scene with suppressive molecules, creating a no-go zone for your immune cells. Your T cells, already exhausted from earlier battles, are stumbling through this chemical haze, unable to mount a proper attack. Here's a light jab. If your immune system was a rock band, the tumour's like a heckler spiking their drinks with decaf mid-show. You can almost see those cancer cells smug in their hideouts, churning out chemicals that tell your macrophages, those hungry janitors from way back, to stand down. Even your natural killer cells, the vigilantes we've been rooting for, are slowed by this molecular fog, like cops trying to chase a suspect through a smoke-filled alley. Now picture the tumour's chemical campaign in full swing. It's not just hiding or spreading, it's actively disarming your immune system, turning the battlefield into a sleepy swamp. Your dendritic cells, which should be sounding the alarm, are muffled by the tumour's signals, unable to rally the troops effectively. And here's another cheeky nudge. Your immune system's like a firefighter trying to put out a blaze while the tumour's spraying them with a hose of tranquilizers. The cancer's outposts keep growing, fueled by those stolen blood vessels we saw earlier, while your defences are left dazed and confused. As you drift through this chemical haze, you feel the tumour's grip tightening. It's not just outsmarting or outrunning your immune system, it's drugging it into submission, making every move harder. Those far-flung metastatic cells are setting up new bases, each one pumping out more of this suppressive fog. You're starting to see why cancer's such a ruthless opponent. It's not just playing defense, it's waging a full-on chemical war. That question about why it's so hard to beat feels like it's sinking deeper into this foggy, disorienting mess. You're still drifting through the foggy, chemical-laced haze of your body's city, where that tumour's far-flung outposts armed with their sedative signals are pulling off another infuriating trick. Those cancer cells, already masters of disguise and escape, aren't just one uniform gang. They're a chaotic mix of different types, like a rogue circus with every act playing by its own rules. This is heterogeneity, the tumour's tricky puzzle, making it a nightmare for your immune system to solve. The mainstream fact is that your immune system's T cells are trained to target specific antigens, like snipers locking onto a single type of enemy. But cancer's not that simple. Its cells are a jumbled mess of subtypes, each with different mutations, like a gang where every member's got a unique tattoo. Some might be fast dividing, others sneaky, and a few might even resist your immune system's attacks entirely. Here's the quirky tidbit. Some tumours have stem-like cells that act like the masterminds, hiding in the back and regenerating the tumour even if your immune system takes out the front lines. It's like the cancer's got its own evil master chef, cooking up new trouble no matter how many dishes you smash. Scientists still debate whether this heterogeneity is a random byproduct of the tumour's mutation frenzy, or a deliberate strategy to keep your immune system guessing. You're gliding closer now, feeling the chaotic buzz of these diverse cancer cells, some tucked in that original fortress, others in those metastatic hideouts we tracked. Your T cells, those sharpshooters we've been following, are trying to aim, but it's like shooting at a kaleidoscope. Every target looks different. Those macrophages from way back, they're overwhelmed, unable to pin down a single type of enemy to gobble up. Here's a light jab. If your immune system was a puzzle solver, it'd be staring at a jigsaw where the pieces keep changing shape. You can almost see the tumour's patchwork army, with cells that dodge T-cell attacks, others that shrug off natural killer cells, and some that just keep multiplying like roaches. Those chemical signals from last time, that foggy sedative mix, are still lingering, making it even harder for your immune cells to coordinate against this motley crew. Now picture the tumour's diversity in action. One cell type might be pumping out PDL1, that do not disturb sign we saw earlier, while another's cranking up different mutations to slip past your immune checkpoints. Your natural killer cells, those vigilantes we love, are swinging at shadows, unable to focus on a single target. And here's another cheeky nudge. Your immune system's like a chef trying to cook for a table where everyone's got a different food allergy. The tumour's heterogeneity makes every attack feel like a half measure, as new cell types keep popping up to replace the ones your immune system manages to hit. As you float through this dizzying chaos, you feel the tumour's strength growing. Its fortress and outposts are like a carnival of rogues, each cell type adding another layer to the puzzle. Your immune system's still fighting, but it's like battling a hydra with a different face on every head. You're starting to see why cancer's such a maddening foe. It's not just a single enemy, it's a whole cast of villains, each with its own script. That question about why it's so hard to beat feels like it's tangled in this ever-shifting, impossible puzzle. You're still gliding through the chaotic, kaleidoscopic mess of your body's city, where that tumour's patchwork army of cells, each with its own sneaky traits, is now dodging a new threat. Treatments meant to take it down. Those cancer cells, with their dizzying diversity, aren't just outsmarting your immune system. They're sidestepping drugs and therapies like a cunning escape artist slipping out of handcuffs. The mainstream fact is that your immune system works alongside treatments like chemotherapy or targeted therapies, which aim to kill cancer cells by disrupting their growth or signalling pathways. But cancer's got a maddening knack for developing drug resistance, like a thief who keeps changing the locks. Some of those heterogeneous cells we met last time have mutations that let them shrug off drugs, surviving while their weaker siblings get wiped out. Here's the quirky tidbit. Certain cancer cells can pump out drugs using tiny molecular pumps, like ABC transporters, spitting the poison back out before it does any harm. It's as if the tumour's got its own bouncer tossing out the medicine before it can crash the party. Scientists still debate whether this resistance comes from pre-existing rogue cells, or if the tumour evolves it under the pressure of treatment. You're floating closer now, feeling the tension, as those cancer cells, whether in the original fortress or those metastatic outposts, face a barrage of drugs but keep slipping through. Your immune system, still groggy from that chemical fog we saw earlier, is trying to help, but the tumour's resistance makes it like fighting a fire that keeps reigniting. Those T-cells, our weary sharpshooters, are struggling to keep up with cells that don't just dodge them, but also laugh off the drugs. Here's a light jab. If your immune system and treatments were a crime-fighting duo, the tumour's like a villain who's read the script and knows every move. You can almost see those cancer cells, some pumping out drugs, others hiding behind new mutations, thriving in their fortified hideouts. Those macrophages, the janitors we've been tracking, might clear some debris, but the resistant cells are too tough, like weeds that keep growing back no matter how much you spray them. Now picture the tumour's resistance in action. A drug like cisplatin, meant to shred cancer's DNA, hits the tumour, but a few cells with those molecular pumps or altered genes survive, ready to repopulate. Your natural killer cells, those vigilantes we keep cheering for, are circling, but the resistant cells are like armoured tanks, barely phased. And here's another cheeky nudge. Your body's like a gardener trying to kill dandelions, but the tumour's got roots that just won't quit. The tumour's diversity, fueled by those mutations from before, gives it a deep bench of survivors, ready to bounce back after every hit. As you drift through this frustrating battlefield, you feel the tumour's defiance growing. Its fortress and outposts are holding strong, shrugging off both your immune system and the drugs meant to help. Your T-cells and macrophages are still in the fight, but it's like battling an enemy with an endless supply of get-out-of-jail-free cards. You're starting to see why cancer's such a slippery foe. It's not just outwitting your body, it's rewriting the rules to beat the treatments too. That question about why it's so hard to beat feels like it's dodging every punch you throw. You're still floating through the tangled, defiant sprawl of your body's city, where that tumour's army of resistant cells dodging drugs and immune attacks is now pulling an even nastier trick. Those cancer cells with their fortress and far-flung outposts aren't just surviving, they're turning your immune system into a double agent, convincing it to protect the enemy instead of fighting it. The mainstream fact is that your immune system's regulatory T cells, or TREGs, normally keep things in check, calming overzealous immune responses to prevent friendly fire like autoimmune diseases. But cancer's flipping this safety switch against you. It's recruiting those TREGs, along with other immune-suppressing cells, to create a shield around its strongholds, damping down any attack before it starts. Here's the quirky tidbit. Some tumours coax myeloid-derived suppressor cells, fancy name I know, to act like corrupt bodyguards, pumping out signals that tell your T-cells to stand down. It's like the tumour's hired a shady security firm to keep your own immune system from storming the gates. Scientists still debate whether this immune suppression is mostly the tumour's doing, or if your body's natural peacekeeping instincts get hijacked too easily. You're gliding closer now, feeling the eerie calm around the tumour's hideouts, where your immune cells seem oddly subdued. Those T-cells, our battle-worn sharpshooters, are being lulled into inaction by this suppressive crew, while the cancer cells keep multiplying. The macrophages we've been following? Some have turned traitor, like those tumour-associated ones we met earlier, helping the tumour instead of eating it. Here's a light jab. If your immune system was a superhero team, the tumour's like a villain who's bribed half the squad to take a nap. You can almost see those TREGs and suppressor cells patrolling the tumour's fortress, waving off your natural killer cells like they're shooing away pesky tourists. The chemical fog from a few stops back, that sedative mix of IL-10 and TGF-beta, is still lingering, amplifying the suppression, making your immune system feel like it's stuck in quicksand. Now picture the tumour's scheme in full swing. It's not just dodging or exhausting your immune cells, it's turning them into unwilling allies. Those metastatic outposts we tracked are also surrounded by this suppressive shield, making it harder for your immune system to even notice them. Your dendritic cells, which should be rallying the troops, are muffled, unable to sound the alarm. And here's another cheeky nudge. Your immune system's like a cop who's been slipped a note saying, "Everything's fine, go home," while the tumour throws a rager. As you drift through this unsettling quiet, you feel the tumour's control tightening. Its fortress and outposts are practically untouchable now, guarded by your own immune cells turned against you. Your T-cells and natural killer cells are still out there trying to fight, but it's like they're facing a mutiny from within. You're starting to see why cancer's such a devious foe. It's not just outsmarting or outrunning your defences, it's turning them into accomplices. The question about why it's so hard to beat feels like it's sinking into a web of betrayal spun by your own body. You're still drifting through the eerie, manipulated streets of your body's city, where that tumour's betrayal has turned your immune system into an unwilling ally. Those cancer cells, smug in their fortress and scattered outposts, are now pulling a wild card from an unexpected corner. Your gut. Yep, the microbiome, those trillions of bacteria chilling in your digestive tract, has a surprising role in this fight. The mainstream fact is that your gut microbiome helps shape your immune system, training T-cells and other defenders to spot threats and keep inflammation in check, like a coach drilling a team for game day. But cancer's found a way to mess with this training camp. Some tumours tweak the balance of your gut bacteria, tilting it towards species that dampen immune responses or fuel inflammation, giving cancer a sneaky assist. Here's the quirky tidbit. Certain gut bacteria, like Bacteroides fragilis, can churn out molecules that either rev up or calm down your immune system, and cancer's like a hacker nudging the dial to calm, to keep your T-cells off its trail. It's as if the tumour's sent a memo to your gut saying, "Hey, tell the immune system to take a break." Scientists still debate whether cancer directly manipulates the microbiome, or if an imbalanced gut just makes it easier for tumours to thrive. You're floating closer now, feeling the distant rumble of your gut's microbial city, connected to the tumour's strongholds by a web of signals. Those T-cells, already bamboozled by the tumour's suppressive tricks from last time, are getting mixed messages from a microbiome that's not quite on your side. The macrophages we've been tracking, they're picking up weird vibes from the gut, making them less likely to chomp down on cancer cells. Here's a light jab. If your immune system was a sports team, the tumour's like a rival coach slipping laxatives into the water cooler. You can almost see those cancer cells, whether in the original fortress or those metastatic hideouts, thriving as the gut's altered signals weaken your immune response. Your natural killer cells, Those vigilantes we keep cheering for are still circling, but the microbiome's influence is like a bad referee throwing off their game. Now picture the tumour's gut connection in action. A shift in bacteria, maybe too many of the wrong kind, pumps out molecules that dial down your immune system's aggression. This helps the tumour's chemical fog. Remember that sedative mix from earlier? Keep your T cells in a daze. Your dendritic cells, which should be rallying the troops, are getting garbled signals like a radio tuned to static. And here's another cheeky nudge. Your gut's like a DJ spinning a lullaby for your immune system while the tumour cranks up the party. As you glide through this strange, interconnected battlefield, you feel the tumour's reach extending beyond its walls. It's not just dodging or suppressing your immune system, it's pulling strings in your gut to tilt the odds. Your immune cells are still fighting, but it's like they're playing with a rigged deck, influenced by a microbiome that's been nudged off course. You're starting to see why cancer's such a cunning foe. It's not just a local problem, it's hacking systems you didn't even know were in play. That question about why it's so hard to beat feels like it's tangled in a web that stretches all the way to your gut. You're still gliding through the sprawling, interconnected web of your body's city, where that tumour's influence, now reaching even your gut, is stirring up another kind of trouble. Those cancer cells, with their fortress and scattered outposts, are cozying up to a sneaky ally: chronic inflammation. It's like the tumour's lit a slow-burning fire that keeps your immune system distracted and, worse, helps the cancer thrive. The mainstream fact is that inflammation is your immune system's double-edged sword, with cytokines like TNF-alpha rallying defences against infection, but also creating chaos if they linger too long. Cancer's exploiting this chaos like a rioter looting in the smoke. Chronic inflammation, often sparked by things like infections or that imbalanced gut microbiome we just saw, creates a stormy environment where cancer cells flourish. Here's the quirky tidbit. Some tumours actually thrive on inflammatory signals, using them like fertilizer to grow faster, almost as if they're sunbathing in the heat of your immune system's overreaction. It's like the tumours turned your body's fire alarm into its personal growth serum. Scientists still debate whether chronic inflammation is more a cause of cancer's spread or a side effect that the tumour hijacks for its own gain. You're floating closer now, feeling the smouldering heat of inflamed tissue around the tumour's strongholds. Your T cells, those weary sharpshooters, are caught in a paradox. They're trying to fight the cancer, but the inflammatory soup, full of cytokines and reactive molecules, makes it easier for the tumour to dodge them. Those macrophages we've been tracking, some are now fueling the fire, pumping out more inflammatory signals that help the tumour instead of stopping it. Here's a light jab. If your immune system was a firefighter, it'd be spraying gasoline while trying to put out the blaze. You can almost see the tumour basking in this inflamed chaos, its cells multiplying as the environment turns hostile to your defences. Those natural killer cells, our trusty vigilantes, are struggling to navigate this smoky mess, their sensors clouded by the same signals meant to help them fight. The chemical fog from earlier, that sedative mix, is mixing with this inflammatory haze, making things even murkier. Now picture the tumour's alliance with inflammation in action. Chronic irritation, maybe from a long-term infection, or that skewed microbiome, keeps your immune system in a constant state of red alert, exhausting it while giving cancer cells a fertile playground. Your dendritic cells, which should be directing the immune response, are sending mixed signals, like a conductor leading an orchestra that's half asleep. And here's another cheeky nudge. Your immune system's like a chef who's accidentally set the kitchen on fire while trying to cook a gourmet meal for the tumour. As you drift through this heated, chaotic landscape, you feel the tumour's advantage growing. Its fortress and outposts are thriving in this inflammatory storm, using the chaos to mask their moves and fuel their growth. Your immune cells are still battling, but it's like fighting in a wildfire where the enemy's handing out matches. You're starting to see why cancer's such a relentless foe. It's not just dodging or manipulating your defences, it's turning your body's own fire against you. That question about why it's so hard to beat feels like it's burning hotter in this inflamed, tangled mess. You're still drifting through the smouldering, inflamed chaos of your body's city, where that tumour, basking in its fiery ally, is now pulling off another brazen heist. Those cancer cells with their fortress and scattered outposts aren't just dodging your immune system or fueling inflammation. They're stealing your body's energy to power their rebellion. It's like the tumour's swiped your credit card and gone on a spending spree. The mainstream fact is that your immune system needs a ton of energy, fueled by glucose and oxygen, to keep T cells and macrophages firing on all cylinders during a fight. But cancer's a greedy thief, hogging those resources for itself. It rewires your body's metabolism, slurping up glucose and nutrients to feed its rapid growth, leaving your immune cells running on fumes. Here's the quirky tidbit. Some tumours use a trick called the Warburg effect, where they guzzle glucose even when oxygen's plentiful, like a kid chugging soda instead of water. This metabolic hijack not only fuels the tumour, but starves your immune cells, making them sluggish and less effective. Scientists still debate whether this energy heist is a deliberate tumour strategy or just a side effect of its out-of-control growth. You're floating closer now, feeling the strain as your body's resources are siphoned off to the tumour's strongholds. Those T cells, our battle-worn sharpshooters, are gasping for fuel, like runners in a marathon with no water stations. The macrophages we've been tracking, already swayed by the tumour's tricks, are too busy in the inflamed chaos from last time to notice their own energy shortage. Here's a light jab. If your immune system was a car, the tumour's siphoned off the gas tank and left it sputtering. You can almost see those cancer cells, whether in the original fortress or those metastatic hideouts, gorging on glucose while your immune cells stumble. Those natural killer cells, our vigilante favourites, are still prowling, but they're like cops on foot chasing a thief in a stolen sports car, outpaced and underpowered. Now, picture the tumour's energy heist in action. It's not just stealing nutrients via those hijacked blood vessels we saw earlier. It's rewiring the whole metabolic neighbourhood. The tumour's cells burn through glucose at a breakneck pace, creating a low-oxygen, acidic environment that further weakens your immune response. Your dendritic cells, meant to rally the troops, are struggling to function in this drained, toxic landscape. And here's another cheeky nudge. Your immune system's like a phone at 1% battery, while the tumour's plugged into a private charger. As you glide through this energy-starved battlefield, you feel the tumour's dominance growing. Its fortress and outposts are thriving, plump with stolen resources, while your immune cells are left scraping by. The inflammatory storm from before is still raging, and now this energy drain makes it even harder for your defences to fight back. You're starting to see why cancer's such a relentless foe. It's not just outsmarting or exhausting your immune system, it's starving it into submission. That question about why it's so hard to beat feels like it's sinking into a drained, depleted haze. You're still drifting through the drained, smouldering streets of your body's city, where that tumour, fattened by stolen energy, is now facing a new challenger. Immunotherapy, the big hope for rallying your immune system. Those cancer cells, thriving in their fortress and far-flung outposts, are up against treatments designed to supercharge your T cells and break through the tumour's tricks. The mainstream fact is that immunotherapy, like checkpoint inhibitors, works by blocking signals, like PD-1 or PD-L1, that the tumour uses to calm your immune system, giving your T cells a fighting chance to attack. But cancer's not going down easily. Despite immunotherapy's promise, the tumour's bag of tricks, disguises, chemical fog and energy heists makes it a tough target. Many tumours shrug off these treatments, either by dodging the boosted immune response or adapting to it like a villain who's read the hero's playbook. Here's the quirky tidbit. Some cancer cells can hide from immunotherapy by shedding MHC molecules entirely, like a suspect shaving their head to avoid recognition. It's as if the tumour's gone off the grid, leaving your revved-up T cells with nothing to lock onto. Scientists still debate whether immunotherapy's failures stem from the tumour's adaptability or limitations in how well we can fine-tune the immune response. You're floating closer now, feeling the flicker of hope as immunotherapy tries to light up your immune system, only to see the tumour dim it again. Those T cells, our battle-scarred sharpshooters, get a boost from drugs like pembrolizumab, but the tumour's heterogeneity, that patchwork we saw earlier, means some cells are naturally resistant, slipping through the cracks. Here's a light jab. If immunotherapy was a gym trainer, the tumour's like that client who skips leg day and still wins at hide and seek. You can almost see your T cells, newly energised, charging toward the tumour's fortress, only to find some cancer cells have changed their markers or doubled down on that chemical fog from before. Those macrophages still loitering in the tumour's manipulated neighbourhood aren't helping much either, sometimes even siding with the enemy, as we saw with those traitor macrophages. Now picture the immunotherapy fight in action. The treatment blocks the tumour's do not disturb signals, letting your T cells and natural killer cells swarm in. But the tumour's not phased. Its metastatic outposts, fueled by stolen blood vessels and inflammation, keep churning out new resistant cells. Your dendritic cells, which should be hyping up the immune response, are still struggling in the tumour's toxic, energy-drained environment. And here's another cheeky nudge. Your immune system's like a boxer pumped up for the big fight, only to find the opponent swapped out for a whole team of lookalikes. As you glide through this flickering battlefield, you feel the weight of the struggle. Immunotherapy is giving your immune system a fighting chance, but the tumour's layered defences, disguises, suppression, and resistance make it a brutal slog. Your T cells and natural killer cells are pushing harder, but it's like storming a castle that keeps rebuilding its walls. You're starting to see why cancer's such a stubborn foe. Even when you bring in the big guns, it's got an answer for everything. That question about why it's so hard to beat feels like it's tangled in a fight that's always one step behind. You're still floating through the battle-scarred streets of your body's city, where that tumour, shrugging off immunotherapy's best shots, is now flexing its ultimate superpower, evolution. Those cancer cells holed up in their fortress and far-flung outposts aren't just resisting treatment. They're adapting and evolving like a species racing through millions of years in fast forward. The mainstream fact is that your immune system evolves too, with T cells and B cells refining their attacks over time to better recognize threats, like a team learning from past games to up their strategy. But cancer's evolutionary game is on another level. Its chaotic mutations, those genetic slot machine spins we saw earlier, let it churn out new cell types that can dodge both your immune system and treatments. It's like the tumour's rewriting its own DNA playbook every time you think you've got it cornered. Here's the quirky tidbit. Some tumours develop clonal selection, where the toughest cells survive therapies, like the last cockroaches after a nuclear blast, repopulating with even nastier traits. It's as if the tumour's running a survival of the fittest contest, and always picking the meanest winners. Scientists still debate whether cancer's rapid evolution is driven by its unstable DNA, or the pressure from treatments pushing it to adapt faster. You're gliding closer now, feeling the restless churn of the tumour's strongholds, where each new generation of cells seems slipperier than the last. Your T cells, those sharpshooters we've been rooting for, are trying to adapt too, but they're like detectives chasing a criminal who keeps reinventing their MO. Those macrophages, still lingering in the tumour's manipulated neighbourhood, are no help, often swayed by the enemy's tricks. Here's a light jab. If your immune system was a chess player, the tumour's like a grandmaster who swaps out the board mid-game. You can almost see those cancer cells, whether in the original fortress or those metastatic hideouts, spawning new variants that laugh off immunotherapy or chemotherapy. Your natural killer cells, our vigilante pals, are still swinging, but the tumour's evolving so fast it's like fighting a shapeshifter who's already 3 forms ahead. Now picture the tumour's evolution in action. A drug might wipe out half the tumour's cells, but the survivors with just the right mutations come back stronger, like bacteria outsmarting antibiotics. The inflammatory chaos and energy heist from before only fuel this evolutionary sprint, giving the tumour more chances to roll the genetic dice. Your dendritic cells, meant to rally the immune response, are stuck playing catch-up in this ever-changing game. And here's another cheeky nudge. Your immune system's like a coder trying to patch a virus that's rewriting itself faster than you can hit save. As you drift through this relentless, evolving battlefield, you feel the tumour's edge sharpening. Its fortress and outposts are like a laboratory of chaos, spitting out new tricks with every round. Your immune system and treatments are still fighting, but it's like battling an enemy that's always one mutation ahead. You're starting to see why cancer's such a formidable foe. It's not just outsmarting or outlasting you, it's evolving faster than you can counter. That question about why it's so hard to beat feels like it's racing away in a cloud of ever-shifting DNA. You're still gliding through the ever-shifting chaos of your body's city, where that tumour, evolving faster than a sci-fi villain, is now dodging the sharpest tools in medicine's arsenal: precision therapies. Those cancer cells, thriving in their fortress and metastatic outposts, aren't just outrunning your immune system or treatments. They're sidestepping targeted drugs designed to hit their specific weaknesses. The mainstream fact is that your immune system works best when therapies, like targeted drugs, zero in on unique tumour markers, like mutated proteins, to help T cells and other defenders pinpoint the enemy. But cancer's a slippery target. Precision therapies, built to attack specific mutations like EGFR or BRF, often miss the mark because the tumour's heterogeneity, that patchwork of cell types we saw earlier, means not all cells carry the same target. Some dodge the drug entirely, while others evolve new mutations to slip away. Here's the quirky tidbit. Some tumours can rewire their signalling pathways, like rerouting traffic to avoid a roadblock, keeping their growth engines humming despite the drug's attack. It's as if the tumour's got a backup generator for every power cut you try to pull. Scientists still debate whether precision medicine struggles because of the tumour's diversity, or because we're still learning to aim these therapies precisely enough. You're floating closer now, feeling the frustration as these high-tech drugs try to lock onto the tumour's strongholds only to hit a moving target. Your T cells, those weary sharpshooters, are itching to join the fight, but the tumour's evolving tricks, remember that clonal selection from last time? Keep it one step ahead. Those macrophages still loitering in the tumour's manipulated neighbourhood aren't much help either, often swayed by the enemy's signals. Here's a light jab. If precision medicine was a sniper, the tumour's like a target doing cartwheels in a funhouse mirror maze. You can almost see those cancer cells, some shrugging off the drug's effects, others sprouting new mutations to bypass it, all while your immune system struggles in the background. Those natural killer cells, our vigilante favourites, are still prowling, but the tumour's rewired pathways make it like chasing a car that swapped engines mid-race. Now picture the precision therapy battle in action. A drug targets a mutation, say in the tumour's growth signals, and takes out a chunk of cells, but the survivors, with their diverse DNA, adapt. Maybe by flipping on a different pathway or hiding the target altogether. The inflammatory chaos, energy heist, and chemical fog from earlier all add to the mess, giving the tumour more room to manoeuvre. And here's another cheeky nudge. Your immune system's like a tech support team trying to fix a glitch while the tumour's already upgraded to a new operating system. As you drift through this high-stakes, high-tech battlefield, you feel the tumour's resilience growing. Its fortress and outposts are like a lab of endless reinvention, dodging even the sharpest tools we've got. Your immune system and therapies are still fighting, but it's like targeting a shadow that keeps changing shape. You're starting to see why cancer's such a maddening foe. It's not just outsmarting or evolving, it's outplaying even our best precision shots. That question about why it's so hard to beat feels like it's slipping through a maze of moving targets. You're still floating through the dizzying, shape-shifting chaos of your body's city, where that tumour, dodging precision therapies with infuriating ease, now faces a glimmer of hope, the relentless push of ongoing research. Those cancer cells, entrenched in their fortress and metastatic outposts, have outsmarted every trick we've thrown: disguises, chemical fog, energy heists, and rapid evolution. But science isn't giving up. The mainstream fact is that your immune system can be supercharged by new therapies, like CAR T cells, which reprogram your T cells to hunt cancer with laser focus, like giving your sharpshooters night vision goggles. Researchers are diving into new frontiers, from tweaking the microbiome to breaking the tumour's suppressive shields. They're exploring ways to outpace cancer's evolution, targeting its weaknesses before it can adapt. Here's the quirky tidbit. Some scientists are studying oncolytic viruses, which infect cancer cells like a Trojan horse, blowing them up from the inside while rallying your immune system. It's as if they've turned a virus into a double agent, working for you instead of against you. Scientists still debate whether the future lies in combining therapies, like immunotherapy with precision drugs, or finding entirely new ways to outwit cancer's tricks. You're gliding closer now, feeling a faint spark of optimism amid the tumour's strongholds. Those T cells, our battle-worn heroes, could get a boost from these new approaches, working alongside drugs that disrupt the tumour's stolen blood vessels or inflammatory allies. Those macrophages, often swayed by the tumour, might be flipped back to your side with clever engineering. Here's a light jab. If cancer's a chess master, researchers are like a team of grandmasters crowdsourcing a checkmate. You can almost see the lab coats buzzing, testing ways to block the tumour's metabolic heist, or unravel its heterogeneous puzzle. Your natural killer cells, those vigilantes we've cheered for, could be armed with new tools to pierce the tumour's defences, cutting through the fog and chaos we've seen. It's a long game, but the tide might be turning. Now, picture this research in action. Scientists are tweaking CAR T cells to hit multiple tumour markers at once, countering that shape-shifting heterogeneity. Others are exploring vaccines that train your immune system to spot cancer early, like giving it a wanted poster for that first rogue cell we met ages ago. The microbiome's role, that gut connection we uncovered, is inspiring new therapies to balance bacteria and boost immune responses. And here's a final cheeky nudge. Cancer's like a hacker who thinks they've cracked the code, but science is writing a patch that might just lock them out. As you drift through this hopeful flicker, you feel the fight isn't over. The tumour's still a formidable foe, with its fortress and outposts holding strong, but researchers are closing in, unravelling its tricks one by one. Your immune system, battered but resilient, is ready for the next breakthrough. That question about why cancer's so hard to beat? It's still there, but now it's joined by a whisper of possibility, a chance that science might finally outsmart this relentless enemy. Let your breath slow now, sinking deeper into the quiet hum of your body city. The tumour's tricks, its disguises, its chemical fog, its stolen energy, feel distant as you drift toward calm. Picture your immune system, weary but steadfast, like a sentinel standing watch under a soft starry sky. The fight's not over, but it's okay to rest. Feel the gentle rhythm of your pulse, each beat a reminder of your body's quiet strength. Let the chaos fade, the fortress blur, as you slip into a peaceful haze. The battle continues, but for now you're cradled in the glow of hope, carried by science's steady march. Sleep easy, dreamer, under the hum of that fan, as the city within you whispers on, sweet dreams,